Okay, so the technique we've been using is to move this decimal point in the second number to make a whole number. In this case here, 0.02 divided by 0.05, we can see that I would need to move that 2 places to make that a 5. I would move that in this one here also 2 places, and what that should result in is 2 divided by 5. And if we check these two sums on the calculator, we see that we get the same answer, which is 0.04. Now, why is it that this and this are the same? Let's have a look. When we have equivalent fractions, 2 divided by 5, if we write 2 divided by 5 as a fraction, we get 2 with 5, 2 on top, 5 on the bottom. Now we know with equivalent fractions, if we've been practicing them, that whatever we do to the top of a fraction, whether it's times it by 10, we need, or times it by something else, or divided by something, we need to do exactly the same to the bottom. And this does not change the value of the fraction, only the appearance. So this 20 divided by 50, or 20 out of 50, or 20 over 50, is exactly the same value as this 2 over 5. Now we can do the same thing, 2 over 5, there, but instead of timesing by 10, we can divide by 10. Divide by 10. And if we do that, we get 0.2 over 0.5. That would be moving the decimal point 1 place. And if we do that again, divide by 10, divide by 10, what we get is 0.02 over 0.05. So here we can see that this, using equivalent fractions, has exactly the same value as this here. And if we reverse that process, we can see that the same thing happens going from 0.02 over 0.05. We can times by 10 there, times by 10, and we're going to get 0.2 divided by 0.5. And if we times that by 10 and times that by 10, what we're going to get is our 2 over 5. So whether we're making decimals out of whole numbers doing this, or making whole numbers out of decimals, as long as we move the decimal point the same number of places in the same direction, the value of the division will be the same.